girls and all my friends have a good weekend. Pages 5 and 6, there might have been a few that you had questions on, so let's take a look at those. Let me get this projector rocking and rolling. So how's the pace of the class been so far? Am I doing okay? Some of you are, when you don't have your homework out and stuff like that, and you don't have it, you keep not doing it, I've got to give you a heads up. You can always redo those worksheets next year when you repeat the course. Okay? And I'm just saying that not to be mean, but a lot of people don't realize that high school education, if you don't pass class, you don't move on. Okay? Unlike middle school. And there's sometimes in middle school you look, it's like, man, the kid has straight F's in middle school. I don't know why they came to high school. Well, they don't. They want to socially promote you in middle school. And hopefully you figure out in high school, but unfortunately sometimes you won't. Yeah.
Do we do like partners in this class?
Partners?
Yeah.
Nah, not really. All right. Let's see. It's trying to connect still. Okay, here we go. Good. What questions did you come across on the homework? Page 5. Just on page 5. That's 1 through 9. Anything there? Remember that has the letter on both sides. Yeah, go ahead.
Number 2.
Okay.
I subtracted 6x from both sides.
Cool. Let's take a look. I see. Okay, so if you subtracted 6x, it's going to be totally right. But what you start realizing, it might goof you up, is you have this now.
Yeah.
Right?
I didn't really know what to do with that.
So you got up to that point, right? I probably would have said, I would have subtracted the 10x and brought it over, but you're still going to be correct. So now I want to try and get x all by itself. I want this all by itself. So I'm going to add 24. And again, remember this, I have this, right? So if I add 24 to both sides, I'm going to wind up with this. And then I divide each side by 4. So x is going to be equal to 6. Is that okay? So your thought process was totally appropriate. It's just if you get a 0 on one side, realize, well, okay, now I have a 0 on one side, but I want to get x on alone, so start moving things on the other side. Anything else on that first page I want to take a look at? 1 through 9. Anything else on 1 through 9? Yeah.
On number 2,
2?
I did a different process, but I still got the
Same answer?
Yeah.
So did you, let's see if this is another way. I would have probably done, my mind would have done it this way. Not that my mind is right. I would have done this. And that would have yielded us the exact same answer as well. You might. What way did you do it?
I did 6x minus 10x and got negative 4x.
There you go. So right there, you got your here.
Oh, all right. I did it a different way. I
Cool.
wrote it a different way.
I got you. But same result. Awesome. So there's different ways to go about it. And the nice thing is, I can't say this is the exact right way to do it because some people will see it that way. Some people will see it where you have the 0 on one side. Everyone has their own mind, which is awesome. Yeah. 8, sure. Number 8. 4 minus 7x equals 1 minus 6x. That one? All right. I have an x on both sides. Agreed? Let's make our dotted. And we have to choose. What side do I want to have the x on? It doesn't matter. I like to get the x to the left side, but it doesn't matter really. So would this be okay? So those are going to cancel. I get 4 minus x equals 1. Cool. And then I would subtract 4 because that's a positive 4. And then I have this negative here. So that basically means, hey, I'm going to multiply that by negative 1 and that by negative 1. So we find that x is equal to 3. Does that make sense?
Yeah.
Cool. What else we got? Anything else from that first side? I know that I'll do the word problem on the back side, or problems. But is there any other questions up to number 15? I'll do the last ones, but I just want to make sure we're good up to number 15. So double check number 15. Make sure you feel comfortable with that. Going good up through number 15? Ooh. It's not my pocket. I don't know whose it is. My message is Rhinestone Cowboy, so you'll hear, I want to be with the lights are shining on me like a rhinestone cowboy. So if you hear that, you know it's me to blame. All right. Anything? Yeah, go ahead.
Number 15.
15. Yeah, right. You guys know that Rhinestone Cowboy is my favorite song, right? Maybe you didn't. I love that song. All right. So on number 15, well, hang on. Find it. Calm down. Flip around. There you go. On this one, the tough thing here is I have this on both sides, or on the same side. Combine that together before you do anything else. So you're going to get 7x plus 16. So I didn't move anything over on either side of the equal sign. At this point, then I can, come on, I can do my dotted line, which means the equal sign. Maybe go here, subtract 7x from both sides. And so what was that? Negative 4x equals 16. Divide each side by negative 4. And 16 over negative 4 comes to just negative 4. Yay? Happy? All right. Let's hit the word problem, okay? Problem number 16 says this. A person is considering buying a new cell phone plan. Yay. Verizon charges $50 per month plus a $100 handling fee. So $50 per month plus $100 handling fee. And then AT&T charges $52 per month with a $50 handling fee. Okay. So write an expression for the Verizon plan. So this one is, the Verizon plan is this. And then the AT&T plan is equal to this. Okay. What number of months will it be the same? So I think this is a pretty good interpretation of things to consider in life. Okay. Hard thing is, are cell phone plans pretty closely related? I'd say yeah. I understand some you'll get some a little bit more. But if you just wanted just a cell phone where you are calling, they're all pretty close. Agree? Let's face it, you don't know, they're not the same as calling?
Well, like in my opinion, it's like a lot of people with their families will have like, oh, I only have like this amount of data.
Yeah.
And then like a lot, like I have unlimited data, other people have unlimited data. So I think it's super different.
But as far as like just a telephone call, like if I was going to call
Like
you.
you just have like a flip phone.
No, I'm just saying if I was going to call, I just wanted my phone to call me to you just on a telephone, not FaceTime, not Instachatgram book or whatever they call them. You know.
Instagram.
I'm just giving you a hard time.
Yeah.
Giving you a hard time. So as far as like an actual telephone call to telephone call, pretty close.
Yeah.
I mean, yes, you can watch some commercials say, hey, look, this covers 99%. Hey, this one is within 1% of that. What's the real truth? It's all massage data, so they're just doing the sales pitch for you. But as far as phone call, I agree. Some, you got unlimited data. Sometimes they'll say unlimited data, but it's like going to come to you as like a little, real slow. So, I mean, there's different categories to different things. So they want us to say, so if you truly knew that you're between these two companies, and let's say these two companies were offering same data rates, same speeds of your phone, and same exact phone. We want to, if one of them says, hey, you got to give me $100 and I charge you $50 a month, and the other place says, hey, you got to give me $50 and I'll charge you $52 a month, because one of them has a higher monthly rate, you're eventually going to get to a point where you pay the exact same amount over time. Okay? So $50 a month plus $100 versus $52 a month at $50. No, general public isn't that bright. A lot of times they might look at the plan on the right, the 52M plus 50, and say, that's great. $50 out of my pocket. What's $2 a month? That's really the mindset. So we're gonna work this out. Let's go 50M plus 100 is equal to 52M plus 50. Maybe we'll subtract, oh, come on. Maybe we'll subtract 50M, 50M. So now I'm going to get 100 equals 2M plus 50. Subtract 50 from both sides. Get a nice trip to see you next fall. So I wind up with M equals 25. What does that 25 represent? Yeah, months. So at 25 months, depending upon what plan you pick, at 25 months, you have now paid the exact same amount of money. And then after 25 months, this one is going to become more expensive. Okay? Because you have a higher monthly rate, even though you paid less. It took you 25 months paying, let's say you have this plan, your best friend has this plan. After 25 months, you paid the exact same monthly rate, all the way through. And then all of a sudden, the person who paid the 100 up front got the 50. Actually, that's a better deal. But, just some things to consider. All right. And then, did I solve that problem? Cool. Yep, we got it. And then number 17. Ooh, look at these cylinders. What do we got here? Yeah. The value of the surface area of the cylinder is equal to the value of the volume of the cylinder. Find the value of x, then find the surface area of the volume of the cylinder. Remember, you know what? 16 and 18. I think that'd be okay to do right at this point. Skip them. Cool? Yay? Happy? If you don't mind, make sure your name is at the top of anything you're handing in and pass it on forward. Please. Did you ever, is that summer package done? Yeah, let's put that in. I'll put it in the book for you. Uh-oh, someone's sleeping. Oh, okay. That's the homework there. Cool. Is that a summer pack? No. Oh. Because I'm not normal.
It was somewhere I think you were on a ball.
All right. I think there was a couple extra pages that written off left on my desk. All right. So we have some notes. Notes. Sounds like a good mint.
Nothing. I didn't say anything. I don't know why you're accusing me.
Ready? So, a few things to note. On Friday this week, we have a small quiz. Okay? We'll just have a small quiz, and it has to do with these linear equations. The person next to you is still chatting means someone's being rude. It's not me. All right, so review the expressions, equations, and inequalities. Hang on, am I on the right? Make sure I'm on the right page. Number 6. Oh, I'm on the wrong page, man. Shoot. All right, I got to reattach my computer real quick or my keyboard. All right. I'm gonna start breaking stuff here in a second. Not purposely. Algebra 1. Should be that one. Is that the one you have now? Oh, good. Whew. Scared me for a minute. I was like, dude, I don't have the right stuff. That's when I get like 5 slides in, you get the one kid. Mr. Stirrup, I don't think you're doing the right thing. Solving multi-step equations with fractions. The skill I'm going to show you right now is a great skill that can be used anytime you have fractions, because we all know that fractions are our best friend. So if we can get rid of fractions, that's better, right? Okay, so let's take a look at this first little operations up here. So if I do 4 times 1/4 x, you want to take a shot at what might happen there? What's going to happen here? What's 1/4 of 4? Go ahead. Distribute 4. So what's 4 times 1/4? 4 times 1 is?
4.
What's 4 over 4?
1.
1. It cancels out, right? So I'm just left with an answer of x for this one. I'll catch up. What's going on here?
Why is it so small? Why is it so small?
Square.
So this just gives you an answer x. What about this one? What do you think is going to happen with that 8? I have an 8 right here, and I have an 8 right here. What do you think happens? It cancels. So what's my answer on letter B? 3x. Okay, because that would cancel that. What's going to happen with the positive 11 and negative 11? Does the 11 cancel? Yeah. Does it stay negative? Yeah, so I get an answer of negative 2x for this one because you have that and then that negative sign. What's going to happen to the 7 on this one? Or the 7s? It will cancel. So what's your answer? 4. Okay. All right. Adding and subtracting fractions. So some of you might have seen this method before. Some of you go get a common denominator. That sounds great. So this is an addition problem, yes? Watch this. Ready? What's 1 times 5? 5. What's 1 times 2? 2. What is 2 times 5? What is 2 times 5? What is 2 times 5?
10.
10. And then 7 over 10 is my answer. So you didn't have to worry about a common denominator here. Letter F, it's a subtraction problem. So what's 3 times 4? 12. For those of you that are standing up. What's 1 times 7?
7.
What's 7 times 4? 28. 12, subtract 7 is 5. I get 5 over 28. So again, if you go through and you do the butterfly method with these, you can add and subtract fractions a lot quicker than getting a common denominator. So again, this is a subtraction problem. 2 times 5 is 10. 3 times 3 is 9 over 15. 10 minus 9 is 1, so I get 1/15. Good? And same thing. Addition problem, 1 times 2, 2. 3 times 4, 12. Over 8. So I get 14 over 8. 14 over 8. 2 goes into both, so I get 7 over 4. That's supposed to be a 7. Cool. So the butterfly method, I know that we've already asked about this, but most of you have indeed seen the butterfly method before. I will always add and subtract fractions using the butterfly method. Okay, it's faster. I wish elementary schools would incorporate it. Unfortunately, they don't. Because a lot of times in elementary school, they're reading you out of a packet. They're not making up. It's like literally in elementary school, the math packets look like this. Tell class to get out a sheet of paper. Get out a sheet of paper. Next step. Tell class to put their name in the top right-hand corner of the paper, include period. That's how a lot of times elementary school math lessons are broken down. And so it's unfortunate. But it is what it is, and we love those elementary school teachers. All right. I don't know what this slide is supposed to be, so I'm skipping it. All right. So, put your pencils down real quick, and pens, and lipstick. Okay, I have 3 denominators up there. Do you agree? I have a 3, I have a 2, and a 3 for my denominators. Is everyone with me in this adventure?
Yes.
You good?
Yes.
Okay, I have 3 terms up there. One of my terms is 1/3 x, another term is 1/2 x, and my last term is 10 over 3. So I have 3 terms. Does that make sense?
Yeah.
A term is either added or subtracted or separated by an equal sign. So I need to figure out what's the smallest number that 3 and 2 go into. Yeah, 6. So what I'm going to do here is I'm going to multiply this by 6, which is the same thing as 6 over 1. This by 6, which is the same thing as 6 over 1. And this by 6, which is the same thing as 6 over 1. I don't have to deal with fractions now. 3 goes into 6 twice. 2 times 1, that gives me 2x. 2 goes into 6 3 times. 3 times 1 is 3x. And then 3 goes into 6 twice. That's going to give me 20. I don't have a fraction to deal with anymore. Does that seem okay? Clearing the denominator is a huge skill that will make these problems a lot more friendly. Okay? Are these like terms? And if so, what do they combine it together to give me? 5x. So I get 5x equals 20. And then I can just do this. What do I do to get x all by itself? Divide by 5? Awesome. So my answer should be what?
X equals 4.
Look at that. So I did not have to work with a fraction. I cleared the denominator. Again, huge skill. If you need to write this down, please do.
What do you do with, like, how does the 10 over 3 work?
Okay, so 3 went into 6 twice, and then I multiplied them.
So you just multiply the first 2 denominators?
Yeah, or you're trying to find, look at all your denominators, and you find what's the smallest number that they all go into. So a lot of times it's just multiplying. Like, don't repeat any of your denominators. So this one we had a 3 and a 2 and a 3. I just used a single 3 and a single 2. Okay. But if you multiplied them all, then you'd get 12. Or wait, 3, 2, and 3. It would have been 18 you would multiply. And the answers still come out the same, it's just they're a little bit bigger. May I move off this screen, or does anyone need more time to talk about it? Life good? Moving on. All right, so I'm going to try and get to the next slide, but it's there we go. Looks like we got some chili peppers there. All right, problem number 1. I have how many terms? 3. I have a over 15 is a term. I have 4 over 15 is a term, and I have 9 over 15 that's a term. Does that feel comfortable? What's my denominator going to be? 15. So if I multiply all three of my terms by 15, what's going to happen? What happens if I multiply all three of my terms by 15? Heck yeah, so that cancels that. That leaves me 9. This cancels this, leaves me what? 4, so plus 4. This cancels that, leaves me what? A. Look at that, there's no fractions. Here's my dotted line. So subtract 4, subtract 4. A is equal to 5. Done. Problem number 2 with the 2 chili peppers. How many terms does it appear that I have? 2, 3. 2/3 is a term. Y is a term. And 3/4 is a term. How many terms? 3. What does it appear is the smallest number that my denominators both have in common? 12. Bless you. So if I multiply this by 12, this by 12, and this by 12, watch what's going to happen. 3 goes into 12 how many times? 4. 4 times 2 is 8. I don't reduce here, so that just becomes 12y. How many times does 4 go into 12? 3. 3 times 3 is 9. Look what I don't have anymore. Fractions, right? Subtract 8. So I get 12y is equal to 1. So what's y equal to? 12y equals 1, so y equals? I just by 12. 1/12. You might result in an answer that's a fraction at the end, but you didn't have to work with them in the beginning if you learn how to clear the denominators. It's a beautiful skill. Trust me. I'm not showing you this skill because it's like, oh yeah, this is going to be mean and demented later. I'm showing you this skill because it'll totally help you in later math and science classes. Am I doing okay? Was that the last slide? No, there's more? How many more? How many more?
2.
One slide or one side? 2 slides.
There's 2 boxes.
Oh, there's 2 boxes. Gotcha. I'm with you. All right. Let's see what this has to offer. All right. Ooh. Okay. This right here is one term. If I distribute 1/2 to here and here, it becomes 2 terms. So 1/2 and then 3x plus 6 is 1 term. If I distribute the 1/2 over the parentheses, it becomes 2 terms. And then the 9 is another term. So a couple ways to go about this problem. I might choose to do this. 3 times half is 3/2. And then what is half of 6? 3. I can totally see that I have 3 terms right now, but I have a denominator of what? 2. So I'm going to multiply this by 2, this by 2, and this by 2. This will cancel. So I get 3x plus 6 is equal to 18. I haven't really moved anything back and forth over the equal sign. Here we go. Subtract 6, subtract 6. Those cancel. Divide each side by 3 because 3x is being held together by multiplication. So I find that x equals 4. Okay? Problem number 4 appears to have how many terms? 3. It has m over 2, it has m over 3, and it has 1. Agreed? What do you think I should multiply all 3 of the terms by to get rid of the denominators? 6. 6, 6, and 6. All right. That goes in there 3 times. So what do I have on this first term? 3m. Good. This is going to go in there twice. So what do I have on the second term? Plus 2m. And then 1 times 6 is 6, right? Whoa, what? I'm making up numbers. I don't know. There we go. Is that we agree? I do have two like terms. I have 3m and 2m. If I combine these together, what do I get? 5m. 5m equals 6. Now let's try and move something over. How do I get m by itself? Divide by 5? Good. So those cancel, so m equals 6 over 5. Totally leave your answer as 6 over 5. Okay? Feeling okay? One more slide? Can we do it?
Yes.
I hope so. Last slide. I have 2 minus 1/4 m equals 3/5. How many terms do I have on number 5? 3. What number do 4 and 5 both go into? 20. So I'm going to multiply this by 20, this by 20, and this by 20. And by doing that, this is going to become 40. There's nothing to reduce on the first part. How many times does 4 go into 20? 5, so minus 5m. And then how many times does 5 go into 20? So that becomes a 12. Make sure you understand why those numbers came too. They reduced, but then I multiplied what was left. What do I do on one side? I do the other. What is that? Negative 28. Right side by negative 5. Negative over negative is positive. 28 over 5 won't reduce, so I just wind up with an answer of 25 over 28 over 5. Last problem. 3 terms. I have 2 denominators. What should I multiply all 3 terms by? 6. Good. All right. So 3 goes into 6 twice. 2 times this 2 is 4, so I get 4g plus, that becomes 3g. And 6 times 14 is 84, I believe. So then I get 7g equals 84. How can I get g all by itself? Divide by 7. So g equals 12. That's it. What do you think? Clearing denominators isn't the worst thing out there, is it? So page 7 and 8 are for tomorrow. I don't think I made enough of those copies to have multiple pages, so you have to make sure you have your book, or you're finding my Schoology page and getting those all taken care of. It's your responsibility for that. Later this week, we're going to check out this Big Ideas book and what you can take home and keep with you, but I'm still not going to check it out yet. Okay?